Hi guys, welcome to my channel at Easy Service on Traverse Computation Part 6. So in this video we are going to show you on how to get the partial coordinates, which is the same thing as the delta northings and the delta eastings on this column. Right, so on our last video we showed us on how to obtain the final bearing, okay, of each successive station. So we are going to be using that information with the distance, the observed distance on site here on this column, to obtain these delta northings and the delta eastings. So just follow us as we journey together. So here we are, what we are going to be using is this particular formula here. Okay, for your delta nothings, you're just going to use this particular equation L cos theta. Your L is for the distance of that station, okay, and the theta is the bearing, the final bearing in this case. Alright, so between these two stations from photo 003 to peg 1, PG1. Okay, the bearing is 51 degree, 9 minutes, 49.40 seconds. Then the distance is 266.442 meters. So we are just going to apply that to get the delta northings. Okay, while for the delta eastings, it is still the distance, but in this case it is sine theta and not cos. So we are just going to be substituting these values for each other to get the delta nothings and the delta eastings of all successive stations. So just follow me as we do that. So now this is just what talking about. To get the delta notice for this particular first station, it is 266.442 meters multiplied by cos, the bearing, final bearing. So we are just going to punch that in our calculator. Okay, 266.442 multiplied by cos 51 degree, 9 minutes, then 49.40 seconds. Then we'll just click on equals. So here we have 167.085. Please, all your values should be in three decimals. Three decimals. So we are just going to write that down here as delta nothings 167.085. Okay, so you don't need to do much, just come to edit it by pressing on this cursor here, this button, and you navigate the cursor to where you have the course so that you can edit it to sine, because we want to get the data E stings. So it is L sine theta and not cos. So here it is L sine theta. So we press equals. So in this case it is 207.543. Please approximate to 3 decimal, just like I said earlier. So we are going to write that down as delta instance 207.543. So that is how we are going to keep doing it for other stations. So in this next station, it is 224.343 meters multiplied by cos this, the cos bearing. We are now going to have the delta nothings. So when we punch that, we have 71.283. So we are just going to pen that down, 71.283. So we'll do the same thing for the data distance. It's just to edit, to sum. And here we have 212.717. So we'll just pen that down. 212.717. So we'll do the same thing for the next station. So for the next station, we have 304.075 meters multiplied by cos. The final bearing here 163 degree, 58 minutes, 52.79 seconds. So when we punch that, we have negative 292.268. So please let the sign be effective, just like what we have above. You can see that it is plus minus theta nothings here, plus minus theta hastings. What that means is that any sign that comes with the value should be effective, that is, should be penned down alongside with the value. So we are going to put a negative 292.268. So that is how it works. So we'll just edit for the data instance. So we are having positive 83.9. So this one is now going to be 83.91. So 83.91. And that is how we are going to be doing it for all other successive stations till we get to the last variable. So therefore, as you can see, we've successfully computed for each other successive stations for the data northings and for the data eastings with signs effective with respect to what we are computing. So if you check now here at this last very end, you do not need to do for any other column where this particular last column ends is going to be at this particular two unknowns. Okay, if you remember, we are having from peg 7, which is 7, to one of the knowns, which is photo 001. Then for this last row, okay, we are having two knowns from photo 001 to photo 003. So we do not do anything here. We are not interested in this particular row because they are already two known controls. So what the aim of the forward computation sheet, this whole thing, is to get the corrected coordinates for the unknowns. So the moment you get to a stage whereby you have two knowns, then you do not have business with it. So where the particular stopped for the two known is just for us to get the correction to bearing that will aid us to distribute to other unknowns. So and that is where it ends. So in this particular row, we have one unknown and one known. So that is where we are going to stop for the data listings and data nothings. So in our next video, we are going to show you on how to do the arithmetic sum for data nothings and the arithmetic sum for the data listings. Thank you for watching. Don't forget to subscribe, share the video, and hit on the notification bell so that you can keep getting first-hand information as we keep uploading our videos. Thank you.